Woohoo! We are here and we are going to be going on a walkthrough of the Math 60 chapters 7 and 8 practice test. Woohoo! I'm going to encourage you to have your calculator ready. This is going to span both chapters 7 and 8. So we're going to be dealing with some radicals right at the beginning and then some other exciting stuff towards the end with quadratics. It's just gonna be a party. This is a 50-point test, but this is a longer test, I think. Let's see how it goes. So definitely keep your hydration close by, and woohoo, let's get started. Okay, number 1. I brought my bear because this is bear math. Woohoo! We've got the 4th root of all of this. Now, you are welcome to use whatever method you like. Since I presented bear math, I'm going to go ahead and use bear math. So here we go. I've got 162 x to the 5th, y to the 11th, wz to the 3rd. So the first thing that I notice is the math teacher is being really cranky with us because I don't want to write y to the 11th. So if you know shortcuts, for example, if you feel comfortable using this index as a denominator for a rational exponent, go for it. Given that, again, I showed you how to use bear math, I'm going to go ahead and use it. What I need to start out with, though, somewhere is a very quick factor tree of 162. I know for sure that 2 goes into it. And then I realized, oh, that's 81. And then 81 is 9 times 9, and that's 3 times 3, and 3 times 3. Okay, so inside I've got a 4 bear, right, because it's the 4th root. I've got a 2 and then 3, 3, 3, 3. Are y'all ready? 5 x's, x, 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 x. Not too terrible. 11 y's. 2, 3, 4, 5, 6, 8, 9, 10, 11. Again, is this the only way to do this? No, not at all. But this is the way that I showed you. And this is the way that I think takes the least amount of hard thinking, and it's the way that it'll work every single time. So now what you want to do is you want to take sets of 4. So for example, I'm hilarious. There are 4 factors of 3. So we're going to get them running. And the bear comes, yum, 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 and eats all of them except for the one that makes it out. Same thing with the x's. Now, with x to the 5th, we realize that I'm going to be able to have a group of 4 of them, plus there will be 1 left in the cabin. And if you haven't seen my video on bear math, then just bear with me, because some of the language I'm going to use is from that video. I'm hilarious. Okay, so 4 of the x's, x to the 4th, and you take the 4th root of that, or 4 x's go running, and the bear comes, yum, 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 and one of them makes it out. Okay, and there's an x left in, and I should probably circle this too before I forget. Then, now, there are 11 y's, which is annoying, because if there were 12, they'd all get to run, but since there are 11, I can make this 4 run, yum, 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 yum. This 4 can run, yum, 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 yum. But then you have 3 left, because 11 divided by 4, right, it goes in twice with 3 left over. W's, nothing. There aren't enough to run. And Z's, even though there are a bunch of them, we need 4 to run. There are only 3, so they get left in the cabin too. So inside the cabin is everybody who didn't have enough buddies. That's 2, that's x, that's 3 y's, a w, and 3 z's. So now let's make this look pretty. 3x y squared times the 4th root of 2x y cubed w z cubed. Now remember that Canvas will change the order of the answers, but when I write up the practice test, apparently I forgot to. So look at that. Our correct answer just happens to be the first one right there. What are the chances? And what are the chances all of them will work that way? I don't know. Let's see. I might have thought to do it. We'll see. La la la. Okay, 1 down, 4 to go. Oh no. Oh, you can't see, so you don't know what I'm worried about. Oh no. Solve this equation. The opposite of s minus 5 equals 2 times radical 10 minus s. So, if someone gives you a list of answers, is it possible just to plug them in and check? Absolutely. But this is a practice test, and the idea is this is something you're practicing. So you can use this. Your score on the practice test doesn't matter at all. But I would encourage you to use this as a learning opportunity, yay, for when you have to do this math in the future. So are there shortcuts? Yes. Can I pay someone else to take my phone and get my steps in for the day? Absolutely. Will it help me? Well, my Pokemons will do better, but it won't actually help me actually, build strength when someone else is doing it for me. So make your choices carefully. Having said that, I know radical equations are some of the nastiest things to deal with in math. And there's no good way around it. So recall that when you've got a radical, when you've got that square root sitting there, you can't solve. The 10 minus s is stuck inside. There's nothing we can do. So basically, we're going to square both sides. So I'm going to square the minus s minus 5. And I'm going to square the 10 minus s as well. I'm sorry, I have little cats and bunnies playing around my feet, which is pretty funny. Okay, over here, some interesting things are going to happen because both of these have minuses in front, and when we square it, we're not going to see a lot of those minuses showing up. So something interesting is going to happen. So over here, I think about either the perfect square and I realize that, oh my goodness, my s's. So how am I going to do this? For right now, because my s's are looking, I don't know that this will help a lot, but I'm going to curl my s's a little bit so they'll look a little fancier, and I'll try to make my 5s with a completely flat top. So I apologize, these are hard to distinguish, but I'm going to multiply this. So I get the opposite of s times the opposite of s, and remember 2 minuses do make a plus, 2 wrongs make a right. So I've got s squared, then plus 5s, and then inner plus 5s, and then minus 5 times negative 5 times negative 5 is 25. Over here, now keep in mind, these are squaring separately, so the 2 squares and becomes 4. And then the square root of 10 minus s, the quantity squared, becomes just 10 minus s. That's what we were going for. Okay, so over here I've got s squared plus 10s plus 25 equals 40 minus 4s. Squiggle. There we go. Okay, let's combine like terms over on the left-hand side. So I'm going to add 4s plus 4s. S squared. Remember that any time you have squares of variables, you want to aim for a 0 on one side of the equation or the other. S squared plus 14s minus 15 equals 0, right? Because we're going to factor and use the 0 property here. Okay, so far so good. Now I have to factor this. It factors as s and s. I know that. And I just have to figure out 2 numbers that I'll multiply to negative 15 but add to 14. How about plus 15 and minus 1? Woohoo! And then once I factor it, then I say, what am I don't have any idea what I was about to say. The words just came tumbling out. My mouth was so excited we were almost done with this. It was going to say, woohoo, there's a pair. And what we're going to do here is we say, well, because of the zero property. Yay, we love the zero property. S plus 15 equals 0, or S minus 1 equals 0. So I'm going to steal space so I don't have to go to the next page if I can help it, so we can kind of look at the whole thing all at once. So either S plus 15 equals 0 or S minus 1 equals 0. I don't know if you can hear on this recording all of the shenanigans going on. Seriously, my cats and my rabbit are the Keystone Cops. So I've got two answers, S equals negative 15 and S equals 1. And you'll notice right up here, the possible answers are 1 and negative 15. 1 or negative 15 or nothing. And that is a hint. That is a reminder that whenever we take an equation and we do something to both sides that hides some of the information. For example, when we square both sides, we create solutions, possibly. Sometimes we do, sometimes we don't. Because remember, right here we had a bunch of minuses, but by the time we square it, the minuses are gone. That's an indication that, ooh, there may be some shenanigans. Also, when you look at the square root, a radical, only positive numbers or 0 can come out of that. When I square it, suddenly I've got a lot more possibilities. This could be negative. This can't be negative, this square root of 10 minus s, but 10 minus s by itself could be. So we may be creating some solutions, so we should always check. Let's check. I'm going to try s equals negative 15. I'd probably start with 1 just because it would be easier. So I'm going to get the opposite of negative 15 minus 5. Does that equal 2 times radical 10 minus a negative 15? So this is going to be 15 minus 5, that's 10. And over here I've got 2 times radical 10 plus 15, that's 2 times radical 25, that's 2 times 5. Does 10 equal 2 times 5? Yes, woohoo! So negative 15 is an answer. Let's try s equals 1. Let's see if I can kind of smush it in here. It's always fun when you can smush. So when you plug in 1, we get negative 1 minus 5. Is that equal to 2 times radical 10 minus 1? Now over here I get negative 6. And over here I get 2 radical 9. So that's 2 times 3, which is 6. Now this is that situation where on the left-hand side we get a negative 6, and on the right-hand side we got a positive 6. This is an extraneous solution. So this is s equals 1 only works in this version of the equation. It does not work up here. And this is one of those solutions we created by squaring both sides. So in other words, if I say I need a number that's equal to 10, you say, well, that's 10. And then if I also say I need a number whose square is 100, you say, well, that could be 10 or negative 10. I suddenly created a new possibility. So this is our new possibility. So of our answers, we go back up and we say, no, s can't be equal to 1 because it gives us this extraneous answer, which is where we get the word extra. It's just a short form, I believe. Or maybe I made that up. Who knows? I'm sure there's an English teacher somewhere you could ask. Or I could look it up, on my magic box. S equals negative 15 is the correct answer. It's the only answer. There's only one answer to this. So it's that one. So just make sure you check your answers before you get them. Okay, we got 2 down, 3 to go. Woohoo! Now, personally, this is 7, 7. This is the complex numbers. I loved complex numbers. True story. I love them so much that I actually did extra work with complex analysis. So when calculus grows up, it becomes something called real analysis when you get really deep into it. And if you allow imaginary numbers in, it's called complex analysis. But we all made a joke that it was complex. Ha ha ha. Anyway, so I love complex numbers. I love imaginary numbers. I think they're really interesting. But I can totally understand that a lot of people look at this and go, blah. One of the nice things about this problem is it's really short. You just have to remember how to do it. So let's talk about what's going on. I've got a complex number, a plus bi form, divided by another complex number. And basically, there's only one solution for this. The only way to resolve or to simplify this is to go ahead and multiply by the conjugate. So you have to remember which is the one we've decided to use. And the answer is mathematicians from a long time ago, like when I was a toddler, like in the 13th, 14th, 15th century. I may be making this up entirely. I was young. It's hard to remember. Back in the olden days. I actually can't remember when complex numbers were first introduced, so I feel like a dork. But I apologize. I'm sure I will look this up. And then you guys could look it up and then we'll all know. But way back in the olden days, somebody decided, look, if we have to choose between making the top look pretty and making the bottom look pretty, and they realized, if we're even going to have to add these things to somebody, we're going to have to do common denominators. I don't want a nasty denominator. We're going to resolve the denominator. So we choose the conjugate of the denominator and multiply top and bottom by it. You're multiplying by something over itself, which is effectively multiplying by 1. So you're not changing the value of the function. You're changing the way it's written. Now, why is the conjugate so interesting? And the conjugate is so interesting because if you have a form something plus the other thing, and then you multiply it times something minus the other thing, you get a difference of squares. So if we FOIL it out, we've got 3 times 3, then outer minus 3 times I, then inner plus I times 3, and last minus I squared. Now, up top, it's just gonna be a disaster movie. There, you can only make either the top or the bottom nice. If we choose to make the bottom nice, which I know it doesn't look nice yet, but it will be, the top is pretty much okay, so let's FOIL this out. 1 times 3, 1 times the opposite of I, so that's minus 1I. Oh no, let's try not to put an I out. Okay. Negative 3i times 3, negative 3i times 3, and then negative 3i times the opposite of I, so that's plus. Remember, 2 minuses make a plus. That's 3i times I. Okay, so let's resolve what we got up top. I've got 1 times 3 is 3, minus 1 times I, so that's minus I. Then minus 3i times 3 is minus 9i. And then plus 3 times I squared is plus 3i squared. Down the bottom, I've got 9 minus 3i plus 3i minus I squared. So, a couple things we can do. We can combine like terms. So we can actually say this is 3 minus I minus 9i minus 10i. And then here I've got plus 3 times a negative 1. Remember that wherever you've got an I squared, you've got a negative 1. That's one of the really cool things about imaginary numbers is I squared. I is the square root effectively of -1. I squared is -1. So I've got 9. These two combine and give you 0, right? They cancel each other out. And then I get minus a -1. And again, this is because of the I squared down here. Okay, we're almost there. I know I said it was short, and now you're like, this doesn't seem short. Well, it's because I'm talking too much. Yeah, well. 3 minus 10i minus 3 all over 9 plus 1. Notice the 3's cancel, so I get the opposite of 10i all over 10, which is the opposite of I. The 10's cancel. Now, you have to write this in the form a plus bi. So this is technically 0 minus 1i, or 0 minus I. And both are acceptable. It depends on the teacher and the book. I am flexible about which one you use. Other teachers may be more rigid, but if we look at the possible answers, I see 0 minus 1i or 0 minus I. Oh my gosh, what's this? What are the chances it would be the first one? It won't be on the practice test. Canvas will reverse, switch up the order. But unfortunately, I did not remember to when I typed this out. And PDFs stay, they don't move around. Thank goodness. That would be, imagine if we were all going to like a magical school and all the PDFs, the answers kept moving around. That would be really cool, but also very difficult. Okay, so what was the takeaway from this one? Remember to match the conjugate of the denominator and the multiply top and bottom by the same thing. Okay, we are halfway through. This is very exciting. Dun, dun, dun. Now we are fully into chapter 8. Yay! Canvas is rubbish when it comes to graphing. So instead of graphing, I'm giving you a problem where you're going to basically describe the graph. So here we have a parabola. F of x equals x minus 3 squared minus 3. Now, the squared part tells us we've got a parabola because nothing else is squared. So this is a parabola. And the number that's out in front here, if it's positive, the parabola opens upward. If it's negative, it opens downward. This one is positive, so it opens upward. That's what we've got. And then you have to remember how to come up with the H and the K. That's the vertex. Remember, the vertex is, if we've got y equals the quantity x minus h squared plus k, then the vertex, and this is just, I know this is yet more stuff to cram in your brain, the vertex is h comma k. And this will help you out if you end up doing these problems. It makes it very quick if you know this. So let's take a look. It's whatever makes this 0, and then when this is zeroed out, you just get y equals k. So in our case, we've got y equals x minus 3 squared. Oops. Ugh, I thought I wasn't going to need to use this. This whiteout tape has been very cranky with me lately. Minus, stay. There you go. Minus 3. So our vertex is going to be, notice there should be a minus here. So since it's x minus 3, we got lucky. The vertex is at positive 3. If this had been x plus 3, this would be negative 3. So inside you take the opposite. Outside you take exactly what it is. Okay, so let's take a look. I know from looking at all of this, I've got a parabola. the problem already tells you have a parabola. The parabola opens upward because that number, the number out in front, is positive. This is upward. My vertex is at 3, -3. Oh my goodness, what are the chances these would all come first? And then, oh look, I changed the order of one thing. This is very exciting. You have to remember where the axis of symmetry is. And the axis of symmetry, if this is the vertex, then the axis of symmetry let me pull that up a little bit higher. Remember, axis just means line. So the line of symmetry that the left side and the right side match up is going to be given by x equals h, whatever that first number is. So in our case, this is 3, -3, so that gives us x equals 3 as our axis of symmetry. And it's this number. It's whatever this number is. And that's just from a parabola that's oriented either upwards or, oh, I can't do it. I don't know how to get my hand turned around that way. So that one or that one, both of them have a vertical axis of symmetry. If you had a sideways parabola, the axis of symmetry would go this way, and then would be y equals. But we've got vertical, so vertical is x equals. So here, it's not the first one. This is so exciting. It's the second one. Woohoo! Oh, I'm excited. Are you excited? So this problem, it actually is a lot easier than it could have been because I can't give you a graphing problem. So again, you're going to be telling me what it looks like. So you're basically going to be walking through the steps. It opens upward. Here's the vertex. Here's the axis of symmetry. Okay, number 5. Woohoo! It's very exciting. And it's probably the hardest problem on the test, but you know it's coming. And, you know, this is just a practice test, but you will be prepared because you know it's coming, and we're going to walk through how you do it. And if you look at the possible answers, you can see that the important number is going to be -6 and 1. So let's talk about how to do this. When you have a quadratic means x squared, inequality, what you want to do is find the critical values by looking at the quadratic equation. So I'm going to say x squared plus 5x minus 6 equals 0. Right? So this is the equation version. So in order to solve this, I need to factor this, and you'll notice I didn't make it hard to factor. It could have been horrible, but it wasn't too terrible. And either you use the AC test, or sorry, the AC method, use the X method, you can use trial and error, you could just guess and check. Pretty quickly you get to +6 and -1, or these two can be in either order. Here's where it gets interesting. When we set these equal to 0, we get our critical values. And remember that the critical values are actually the opposite of what you think they're going to be. If you have x plus 6, the answer is, the number you want to look for is -6. If you have x minus 1, the number you want to look for is +1. Okay, so these are the critical values. And so these are the places where this expression equals 0. And I waved my arms a lot, and I did all these things when I did the videos, basically to say, when this quadratic expression passes from a positive to a negative or negative to a positive, it has to go through 0. So these are the only two places where this expression can pass through 0. So if I've got a number line, it doesn't have to be beautifully drawn or anything, and there's -6, and there's +1, then I know that this expression x squared plus 5x minus 6 is 0 here and is 0 here. And what I want to do, my cat is trying to get my attention, as you can tell. Either that or he's making suggestions and I just can't hear him. Let me listen more carefully. You should try picking points in between the critical values. Oh my gosh, Galaxy, you're right. Oh my gosh, he's actually been listening to so many lectures. My cat now knows how to solve this. One of my cats. The other cats don't care. Honestly, they don't. They're like, hey, why do I have to do math? You feed me, I've got sunshine, life is good. I'm not going to do math. But the rest of us are like, but math is so cool, you're missing out. And then that's why these videos are so long. Okay, I'm back to the work. So my critical values are here. I know that this expression equals 0 at these 2 points. I have to pick a point in between. What number comes between -6 and 1 and is really easy? Can I suggest the number 0? This is going to be one of my test points. So I'm going to test 0. So at 0, if you plug 0 in, you get 0 squared plus 5 times 0 minus 6. That's 0 plus 0 minus 6 equals -6. So that is a big fat negative. So this expression is negative in between here. And I'm going to use pink for that because I don't have a red highlighter. And pink is to be in the red is to be negative. So now I need to pick a number to the right of number 1, and it could be anything. I'm just going to go ahead with the number 2. This is not to scale. And I get 2 squared plus 5 times 2 minus 6. So that's 4 plus 10 minus 6. 14 minus 6 is 8. That's positive. Right? So this is positive. And why do I know it's positive for the whole region? Well, I know that it's positive all the way in there because when can it switch from positive to negative? It can only switch from positive to negative where it hits 0. Right? You can only go from positive to negative. No matter how wiggly you go, you have to go through the 0 point. So it's 0 right here, so I know there's a switch. Now, could you have a point here, and then it goes negative, and there's a point, and then another negative? And the answer is yes. That does happen sometimes. Now, what are we guessing? Well, I'm going to guess that this is going to be positive, but I don't know for sure. Pardon me. Sorry, I had to sneeze. You know, I'm so allergic to negative numbers. Okay, so I'm going to pick a number. I'm not going to go too far. I'm going to pick -7. If you want to, you know, have fun. I know, have fun is a weird thing to say. But if you want to pick -1,000,000, pick -1,000,000. If you want to pick -100 or -10, go for it. So over here, I've got -7 squared plus 5 times -7 minus 6. So I've got positive 49, because again, 2 pluses, minus 35 minus 6. Pardon me. 49 minus 35 is 14, minus 6 is 8. Now, you might be interested to see there's symmetry here. Remember we talked about that axis of symmetry? And if I go 1 point to the right and 1 point to the left, I end up in the same place for the y value. There is symmetry to quadratics, so that's pretty cool. So that's positive. So here it's positive. This is negative. This is positive. So this is positive here. Okay, so I'm having lots of fun with my hand. Oh my goodness. Oh my goodness. Wait, is that Godzilla stomping all over my bad answer? Why, yes, it is. I swear it was my cat. My cat distracted me. Okay, let's try this again. It's positive, which we talked about being green. Yay, Queen. There we go. Shh, don't tell anyone I did that. No one will know, except for the 3 people who watch this video. Okay, so we all have a secret now. We're bonded by a blood oath. Don't tell. First rule of Math Club, do not tell about Math Club. Okay, so I've got positive values here, negative values here, positive values here. So now we go way up to the front, and we go, okay, I want this expression to be greater than 0. So, what are we looking for? If I want x squared plus 5x minus 6 to be greater than 0, we want positive values. So we're looking for the green. So the green sections are everything to the left of -6 and everything to the right of 1. So that would be all the way from -infinity up to -6, exclusive. We don't want to include -6 because it's equal to 0. And since this is strictly positive, we can't include the endpoint. I'm going to jump over, so I'm going to put a union here to tie these two together, and then we're going to start up at 1 and go as far as we want in the other direction. Okay, so let's see if we can find this. Oh, this is very exciting. I didn't put it first. So remember, it's -infinity to -6, and then 1 to infinity, all with parentheses, no brackets because it's exclusive. Oh my gosh, look at it. It's right there. And we're done. And you guys are amazing. You got through it. This is not an easy thing. So we did it. It's 36 minutes, so it's a long video. Hopefully you were hydrating. Yay, hydration. I love this little design there. Yay, hydration. Yay, math. Take a break. Rest your eyes. Go out and look at green things for a little bit so that your eyes don't go all funny. And, you guys are awesome and amazing, and math on.